Good afternoon, ladies and gentlemen. Let's continue. We have one more session. Maybe it's going to take like 30 minutes. Okay. So I will finish this related rates. Now, once again, I suggest everybody to practice every problem if you have time. As you practice more and more, you actually improve really your understanding skill and also your vocabulary, and it really improves your problem solving skill. Why? Because these problems you have to read, you have to understand, you have to model it, then you have to solve this. You have to go through like a few steps. Okay. And also in midterm, I think most questions will come from this subchapter, that is related rates. Okay, so let's continue then. In the previous section, we did a few examples. I think we just stopped here, and I'm going to need more space. Let me just add one more space here. So that's all right. So here we have 5, 6, 7, and that's it. And after that, if you have any questions, I'll try to answer, and we will finish today's class. So in this question, a police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. When the cruiser is 0.9 kilometers north of the intersection and the car is 1.2 kilometers to the east, the police determine with radar that the distance between them and the car is increasing at 30 kilometers per hour. Okay. If the cruiser is moving at 90 kilometers per hour at the instant of measurement, what is the speed of the car? Okay. So now, of course, if you are doing this question for the first time, it is not that much, not difficult. It's not that much easy. And you have to read one more time. If you don't understand, you have to read one more time. And after that, sentence by sentence, right? And of course, to understand better, you need to draw the picture. What is going on here? So number one, it says that a police cruiser, right? A police cruiser here, the police cruiser is approaching a right-angled intersection from the north, is chasing a speeding car that has turned the corner and is now moving straight east, right? So that means that now if I just draw our this coordinate system, right? And this one is north, this one is east, and this one is, what is it? West. And actually we don't need them, it's just why it is south. So actually, maybe I need to draw this line somewhere here. Okay, this one is east. So our police car is coming somewhere here. All right, that is a police car. Let's say P, police cruiser. And what is it? The race car. It is somewhere here. Let's say it is R, right? It is moving towards this intersection, and this car is moving towards east. That is the first part of the sentence, the question. When the cruiser is 0.9 kilometers north of the intersection, so that means that what is it? This coordinate is 1 is 0.9. Let me just denote this y. When y is equal to 0.9 kilometers north of the intersection, and the car is 1.2 kilometers to the east, right? The position of this r is, that is 1.2 kilometers to the east, means the position of r. That is on the x-axis, that is 1.2 kilometers to the east. And the police determined with radar that the distance between them. What is the distance between them? The distance is the shortest distance, right? We are talking about this distance. Okay, let's say the distance is, it is S. The distance between them, the car is increasing at 30 kilometers per hour, right? So at this instant, what is ds dt? ds dt is equal to 30 kilometers per hour. If the cruiser is moving at 90 kilometers per hour at the instant of measurement, right, at that moment, that means that the rate of change of, what is it, the position of the cruiser, that means that dy dt at when actual y is equal to 0.9 is equal to 90 kilometers per hour. What is the question? What is the speed of the car? The speed of the car is how fast is it moving away from the origin? So that means that the question is here, we need to find this dx dt at that instant, right? What is the instant that one actually y is equal to 0.9? That is a question. For because really, guys, you need to read this well. If you don't understand, read one more time and sentence by sentence, try to understand what is given. Just give out everything. Draw the picture by the given data. And after that, now we try to solve this question. Now, okay, here, since again, that is the intersection, right? It actually makes a right angle triangle. So at the instant, right? At any instant, actually, let's say this P is Y kilometers away from this intersection, and this R is X kilometers away from this section. Now, how can we actually model, I mean, the right an equation that connects the distance between these two cars, right, and how far they are away from the origin or from the intersection. So using just Pythagorean theorem, now we have this equation: s squared is equal to what we have here, p squared. Actually, p is just y. Let me just write here y. First, let me just write here x squared plus y squared, right? So because at time change here, three things are changing, right? Position of P, it is changing. But also actually the magnitude of S, it is changing. Position of R, it is changing. Actually, they are depending on what? They are all dependent on time, right? So that means that S is a function of T, X is a function of T, and Y is a function of T. Okay, so that's it. So now what are we going to find here? dx dt when y is equal to 0.9. So now if you differentiate both sides with respect to t, what do we have here? 2 times s times ds dt. On the right hand side, we have 2 times x times dx dt. Plus, here we have 2 times y times dy dt. Okay, so now if you just divide all numbers by s, right? And I'll try to leave this dx dt alone. So here we have then dx dt, right? And take this y times dy dt to the left hand side. And here we have, and after that also I divide by x. So what do we have here? S over x times ds dt. Plus, this one is not plus, actually it is minus. So minus, here we have y, that is y over s or x? No, it's x, because you are dividing both sides by x. So y over x, here we have dy dt, right? So when y is equal to 9, again, from this equation, actually, we can find the value of s and x and everything, right? So when y is equal to 0.9, x is equal to 1.2, right? If you substitute there from that equation, what we have here? Here we have, where's my paper? Okay. So from here, we know that x squared plus y squared is equal to s squared. I don't want to use. Now from here, when actually y equals 0.9, x equals 1.2. So s squared is equal to 0.9 squared plus 1.2 squared, right? 0.9 and 1.2. So which is equal to 9 squared is 81, 0.81, and 1.2 squared is 1.44. And the 144 plus 81, that is 225. That is 2.25. Now from here, what is s square root of this number? That's equal to 1.5. So at this instant, the distance between these two cars was 1.5. Now, if I just substitute this into this equation, right? What do we have here? dx dt. So here we have dx dt, dx dt. At that instant, that means that when y is equal to 0.9 is equal to, is it? Yes, y is equal to 0.9. Here we have s over x. S over x, s is 1.5, x is 1.2. And here we have, what is it? ds dt. ds dt, and also ds dt is given here, right? ds dt is 30 kilometers. So ds dt is times, here we have 30 kilometers, minus, after that we have y over x. Y is 0.9, x is 1.2. So here we have 0.9 over 1.2. And what we have here, dy dt. dy dt also given, it is 90 kilometers per hour, right? And also here, if you notice this y, right, it is approaching zero, right? So actually, it is decreasing here. And that's why it must be negative. Um, so here we have times minus 90. So now if you simplify this, 1.5 is 15 over 12 by 6, 15 times 5 by 6, it is 2. Minus, here we have 9 over 12 by 3, it is 3. It is 4 times 90. With this minus, it is plus, which is equal to, okay, here we have 75 plus 90 over 4, that is 45 over 2. 3 times 45, 135. And here we have, what is it? Common fact, denominator is 2. That is 210, 210 over 2, which is equal to, 105 kilometers per hour. So that means that at that instant, that actually the racing car, right, it is moving away from this origin at the speed of 105 kilometers per hour. Okay, Mesa, any questions?
No, sir.
Is everything clear, Mesa? Do you understand everything, or it's too easy for you?
No question for now.
Good. If there's no question, everything is beautiful. Let's continue. Okay, that's our last question. Oh, we have two more questions. Good. A particle P moves clockwise. Now we have clockwise and anti-clockwise, but here it moves clockwise at a constant rate along a circle of radius 10 feet centered at the origin. So actually here we are given a circle and the point is on the circle. It is moving in anti-clockwise direction, okay, along this circle. Okay, that's the first part of the sentence. The particle's initial position is 0, 10. And 0, 10 is, it is here, right? Initial position is here. And on the y-axis, and its final destination is the point 10, 0. So final destination is here. When it just reaches the x-axis, it stops moving. Once the particle is in motion, the tangent line at P intersects the x-axis at a point Q, which moves over time, right? If you just draw a tangent line, when it is on the y-axis, we cannot draw this. When it's on the x-axis, we cannot draw this. We can draw this, but one it will be horizontal, one will be vertical, right? As this point moves, right, and also actually this tangent line, it is moving. So once the particle is in motion, the tangent line at P intersects the x-axis at a point Q, which moves over time. Okay, if it takes the particle 30 seconds to travel from start to finish, means from point on the y-axis, right? Start finish means from this point 0 to 0, 10 to 10 to 0, right? This 0, 10 is the initial point, this 10 to 0 is finish point. Okay. 30 seconds to travel from start to finish. How fast is the point Q moving along the x-axis when it is 20 feet from the center of the circle? Okay, so now again, if any point, actually that Q point, if I just denote this by x, right, that is x units away from this. So at the time, what is the question here? The question here is I need to find this is dx dt, right? When it says that Q moving along the x-axis when it is 20 feet from the center of the circle. That means that when x equals 20 feet, we need to find the rate of change of this x with respect to time t. Okay, that's the question. So now, first, actually, we need to make, again, we need to write our equation that connects what is changing here. Point P is changing here. Theta, it is changing here. And also Q changing here, right? We have three different variables here. So how to make connection here? from this picture, as you see here, if you draw a tangent that is always perpendicular to this line segment, the line segment is its radius, right? The radius is always perpendicular to the tangent. Okay, so that means I can write the tangent function. Then what is tangent of theta? Tangent of theta is equal to, right, in the right angle triangle, opposite side over adjacent side, right? Actually, opposite side over adjacent side, it doesn't, I don't need this because opposite side, I don't need the opposite side. I need actually the base, right, the x. So what is adjacent side over hypotenuse? Right? Or simply, actually, here we have cosine of theta, right? Cosine of theta, what is it? Adjacent side, that's equal to tan over, right, hypotenuse. What is the hypotenuse? That's equal to x, okay? Now from here, what is x? X is equal to 10 times 1 over cosine of theta. Or just simple, that's equal to 10 times secant of theta. Okay, that is how x and theta are related to each other. Okay. So now, if I differentiate this again with respect to x, both sides, what do we have here? dx dt is equal to, on the right hand side, I have 10, right? And what is the derivative of secant of theta? Derivative of secant of theta is equal to secant of theta times tangent of theta. And we have already studied this. And times theta is a function of t here. Also here we have d theta and dt, right? If you differentiate secant with respect to theta, it is secant of theta times tangent of theta times, and differentiate theta with respect to t, it is d theta dt. Okay, so now I need to find actually when x is equal to 20, right? When x equals 20, what are the values of, for example, the theta, right? And also d theta dt. What is it? Number one, when x equals 20, right? When equals 20, now from this relationship, what is x? Or let's say when x equals theta from this relationship, right? It is 20 is equal to 10 times secant of theta, right? From here, secant of theta is equal to 2, right? So if secant of theta 2, I know the value of secant of theta now, I can get the value of tangent of theta, right? So if you just draw a right angled triangle here, okay, suppose that this one is theta, and secant of theta 2 means actually opposite side is 2. Opposite side is, I mean, the adjacent side is 1, and hypotenuse is 2. So it is 4. This side should be square root of 3. And also you can find angle actually. Without this also I can find this. So then what is tangent of theta? Tangent of theta is opposite side over adjacent side, that's equal to square root of 3, right? And how about d theta? How actually this angle is changing? At the beginning it says that it takes the particle 30 seconds, right, to travel from start to finish. So that means that to travel from start to finish, actually, what is actually the distance it traveled? I mean, the point traveled, point P traveled. It is just one fourth of the circle, right? So that is 1/4 of the circumference. That is 2 times pi times r, which is equal to 1/4 times 2 times pi times what is r? It is 10. So that's equal to 5 pi. Okay. 2 pi r, 1/4 pi for 5 pi. Okay. So now I can just write here in 30 seconds, right? It can travel 5 pi, right? And everything is in minutes because it says that, okay, circle and per second, 30 seconds, feet from the center. All right. Over time. Okay, good. So 30 seconds, either I have to express this length per minute or per second. But here, if you just multiply both sides by 2, here we have 60 seconds. That means 1 minute, 2 times 5, that's equal to 10 pi. Okay. So what does 10 pi? It means that every minute, right? Every minute, this particle is covering a distance of 10 pi units. Okay. So actually, that's a speed. That is, what is it? Distance. No, why am I finding the distance? Sorry. I need to find theta, right? Not the distance. So here in 30 seconds, it traveled how many actually? What is this angle? In 30 seconds, it actually covers an angle of pi over 2. Now, how about in 1 minute? If you just multiply by 2, it is 1 minute. Multiply by 2, it is pi radian. Okay, that means that in 1 minute, it just covers or it actually swipes an angle of pi radian. So what is it actually? That is d theta dt, right, per unit of time. That's equal to pi. So now if I just substitute here, then it is 10 times secant of theta, that's equal to 2 times tangent of theta, that's equal to square root of 3 times, and the d theta dt, that's equal to pi, which is equal to 20 square root of 3 pi, okay, at that instant, when, actually this one is when x equals 20. So that means that when x is 20 units away from the origin, it was moving toward the origin at, what is it, dot, dot, dot. The answer is minus 20 times square root of 3 times pi. Okay. It is minus. Why it is minus? Because it is decreasing, right? That's why it should be minus. Okay. The last question about related rates. Again, guys, if you when you are practicing, actually we have solution manual, but still, if you are not sure about any question, just let me know the number, and again we can meet and or in my next class we can discuss those questions. Okay. So the last question. Water is flowing at the rate of 6 cubic meters per minute from a reservoir shaped like a hemispherical ball of radius 13 centimeters. Okay. So the volume of water in the hemispherical ball of radius r is this when the water is y meters deep. Okay, that is actually just a formula, but also we will get this formula when we study integrals, okay? Because without using integral and finding this volume is not easy. Anyway, so actually we have hemispherical bowl, right? And water is flowing into this bowl. And of course, the level of the water, right? The height of the water is increasing. So when the height of the water is y meters, at the time the radius of the top of the spherical bowl, I mean the water level, it is just r centimeters or r meters. The question, at what rate is the water level changing when the water is 8 meters deep? Right. So at what rate is the water level? So that means the water level is y. So we need to find dy dt, right? When water is 8 meters deep, when y is equal to 8. So we need to calculate this. Second one, what is the radius r of the water surface when the water is y meters deep? So that means that here from here, we need to find what is r in terms of y. So now at what rate is the radius r changing when the water is 8 meters deep? The next one is, what is it? We need to find dr dt by the change of rate of r with respect to t when y is equal to 8 meters. So these are the questions we have to answer. Let me just start from the first one. Here we have, okay, A. Askara, are you there?
Yes, sir.
Askara, where are you now? In Phnom Penh or are you from Phnom Penh?
No, I'm staying in Phnom Penh. I'm not going to.
So right now you are in Phnom Penh, right?
Yes.
Good. All right. So, Askara, how is your day? Can you tell us about one day? How are you spending your time? The whole day, are you staying home or you can go out?
Sometime I'm staying home and sometime I'm doing.
Yeah, everybody, sometimes they stay home, sometimes they go out. But how, what does sometimes mean? Once a week or once a year?
Maybe 1 week.
Once a week. Oh my gosh. Okay. All right. Okay, let's continue then. That's the last question. If the question is clear, the formula is given, the amount of water in this, right? So what we have to do here is we need to find dy dt. Now from this, actually, first, let me just simplify our v. V is equal to, if you remove the brackets here, we have what is capital R? Capital R is the radius of the sphere, right? It says hemisphere ball of radius R, right? So this R, we know that that's equal to 13. That is the radius of the spherical hemispherical ball. So if you actually remove the brackets, what we have here, this 3 cancels each other. R is equal to 13, right? So here we have 13 pi. Actually, here we have y squared minus pi over 3 times y squared times y. So that is pi over 3 y cubed. Okay. So now if you differentiate both sides with respect to t, then dv dt is equal to, the first part is 26 pi, and here we have y, and here we have dy dt. Minus, second one is 3 comes to the front, here we have pi times y squared times dy dt. And dy dt is a common factor here. I can just take this out, 26 pi y minus pi y squared times, here we have dy dt. Okay. And we know what is the rate of flow, right? That is 6 meters cubed per minute. What is it actually? That is dv dt. That's equal to 6. So we know what is dv dt, right? Now actually, we need to find this dy dt. So from here, if you find dy dt, what is dy dt? Dy dt, right? When y is equal to 8, that is equal to 8, that's equal to, on the left hand side, dv dt, that's equal to 6. I have 6 here, over 26 pi times y is equal to 8, minus pi times here y, it is 8 squared, right? Which is equal to something, okay? So you can just simplify this, and if you just do this, let's see what we got here. 6, okay. Here we have 6 over 26 times 3.1 to 142 times 8 minus 3.142 times 64. That's equal to, actually, in fraction, that's equal to 1 to 5 over 949,426. Okay, dy, it is meter per minute. Okay, so that is the first part. The second part is, how do you find the second part? I need to find v. Okay, I need this picture. Sorry. And question B, it says, what is the radius R of the water surface when the water is y meters deep, right? So what is R from here? If this one is y, the radius is 13. So this remaining part should be 13 minus y. And this radius is R, right? It is right angled triangle. So what is R then? Here, R squared is equal to 13 squared minus 13 minus y squared, which is equal to 13 squared. 13 squared is gone. Here we have minus, that is plus 26y minus y squared. So from here, R is equal to square root of 26y minus y squared. And it's just radius, that's why we're just taking the positive root, right? Okay, that is R. That is part B. So that is how R and Y related to each other. And part C now, the question part C, it says that at what rate is the radius R changing when the water is 8 meters deep, right? So that means that again, we need to find here dr dt when y is equal to 8. So now we need to differentiate this. How can we do that? We know that that's just equal to 26y minus y squared and to the power of 1 over 2. So now from here, if you differentiate both sides with respect to t, right, 1 over 2 comes to the front, 1 over 2 times 26y minus y squared to the power of minus 1 over 2. Now we need to differentiate inside, right? So that is inside, if you differentiate this, that is 26 minus 2y, right? Times, now we have to differentiate y with respect to t. That is dy dt, okay? So when y is equal to 8, so we need to evaluate that thing. 1 over 2 times 26 times 8 minus 8 squared to the power of 1 over 2 times 26 minus 2 times 8 times what is dy dt? At that instant, we have already calculated here. Dy dt is 1 to 5 over 946, 1 to 5 over 9, 4, what is it? 9426, 9426. Okay. So now if you evaluate this, we will actually get the rate of change of this radius at that instant. So here, what is it? It is, let me just simply write this, 1 over 2 times square root of 26 times 8 minus 64. That's equal to 144. Actually, this one is 144. So here we have 144 to the power of minus 1 over 2 times 26 minus 16. Here we have 10 times 125 over 9426, which is equal to, in the fraction, we have, what is it? 1250 over 2 times, it is 12 times 9426, which is equal to 625 over 113112, 31113112, and which is approximately, what is it? It's a very small number. That's exact value actually. That's just exact value. What is it? It is meter per minute. That is the rate of change of the radius. Okay, guys, that's it about related rates. As you see, the most important thing is understanding the problem and write down the given information, draw your picture, and after the how things are related, write your equation. Actually, that is the most important task in math, okay? If you can do this, the rest is just simple calculation, all right? So practice some questions. Tomorrow we'll talk about linearization, and Friday I will see. If I cannot finish tomorrow, we will have class on Friday. Otherwise, you need to prepare for your midterm, okay? Next Monday, you will have midterm. Actually, midterm time is 90 minutes. You will be given 90 minutes and questions will be multiple choice questions, okay, online. So it starts maybe around 4:30 something until 6 o'clock. All right. Thank you very much. Have a good day. See you tomorrow.